Hello mom, good morning. I am Mary Grace Tunyakaw and this is my topic for today is sickle cell anemia. So here's where the presentations begin. So what is sickle cell anemia? So sickle cell anemia is a blood disorder that affects hemoglobin, the protein food in red blood cells that helps carry oxygen throughout the body. Occurs when a person inherits two abnormal genes that cause the red blood cells to change shape. So, as we can see the picture, the normal red blood cells form a circle shape, then the curved shape is a sickle cell. So, let's proceed to cause the sickle cell anemia. So, sickle cell anemia is caused by a change in the gene that tells the body to make the iron-rich compound in red blood cells called hemoglobin. So hemoglobin enables red blood cells to carry oxygen from the lungs throughout the body, and then sickle cell anemia causes red blood cells to become rigid, sticky, and misshapen. So, as we can see, the normal red blood cells flow freely within blood vessels. So, then the cross-section of red blood cells is a normal hemoglobin. Then, the abnormal sickle cell red blood cells, sickle cell, abnormal red blood cells, sickle cell blocking blood flow because of the sticky sickle cells. Then the cross-section of sickle cell is abnormal hemoglobin. Form strand that cause sickle shape. So next is people with sickle cell anemia inherited disease from their biological parents. In sickle cell anemia, the blood cells mutates or change hemoglobin protein gene from both biological parents have sickle cell anemia. So for a child to be affected, both mother and father must carry one copy of sickle cell trait and pass both copies of the altered form to the child. So if only one parent passes the sickle cell gene to the child will have sickle cell trait. So let's proceed to the effects of sickle cell anemia. So sickle cell anemia that affect your red blood cells, it's one of the most common and usually most severe forms of a group of red blood cells disorders, sickle cell disease. In order to survive, your body needs red blood cells to supply oxygen to its tissue. A person with a sickle cell disease has bone marrow that produces red blood cells with defective hemoglobin, S or sickle. But if the bone marrow is replaced with a healthy bone marrow, a person's body may start to produce a normal hemoglobin. So, bone marrow is a spongy center of bones that produces blood cells. Stem cells in the bone marrow produce red blood cells, white blood cells, and platelets. Bone marrow stem cells in people with sickle cell disease produce abnormal sickle red blood cells. So, we have four types of sickle cell disease. The four types of sickle cell disease anemia are caused by different mutation in these genes. So the first one is hemoglobin, SS or sickle cell disease. So people who have this form of SCD inherits or sickle cell disease inherit two genes, one from each parent that code for hemoglobin S. Hemoglobin S is an abnormal form of hemoglobin that causes the red blood cells to become rigid and sickle-shaped. This is commonly called sickle cell anemia and is usually the most severe form of the disease. So, hemoglobin S is an abnormal that causes the red blood cells to become rigid and sickle-shaped. So, the second is hemoglobin SC. So, is a type of sickle cell disease, which means it affects the shape of the red blood cells contain a protein called hemoglobin, which is responsible for carrying blood throughout the body. So, people with hemoglobin SC disease have red blood cells that are differently shaped and therefore do not carry oxygen as effectively. So the third one is hemoglobin SB plus or beta. Thalassemia affects beta globin gene production, the size of red blood cells if inherited with the hemoglobin S gene. You will have hemoglobin S beta thalassemia. Symptoms are not as severe form. So, hemoglobin SB plus is some problems can include low red blood cells count, pain, and risk of infection. So the next one is the last is hemoglobin SB 0 or beta 0 thalassemia. Sickle beta 0 thalassemia is the fourth type of sickle cell disease. It also involves the beta globin gene. It has similar symptoms to hemoglobin S anemia. However, sometimes the symptoms of beta 0 thalassemia are more severe. And when a person has one copy of hemoglobin S and one copy of beta thalassemia, it is called sickle beta 0 thalassemia. So sickle beta 0 is a blood condition that is similar to sickle cell anemia. So let's proceed the symptoms of sickle cell anemia. First is shortness of breath. So as intense tightening in the chest or difficulty breathing, breathlessness, or a feeling of suffocation. So the next is fatigue. So a feeling of constant tiredness or weakness. So next is delayed growth in children. So when he is small for his age but grows for a long period of time compared to other children, often reaching a normal height. Then is yellowing of the eyes and skin. So jaundice is when your skin or the white of your eyes turns yellow. Then the next is cells can get stuck in veins. So blood vessels can get stuck and black blood flows throughout the body, causing pain. So organ damage. So we have lungs, kidneys, spleen, brain. And the last one is high blood pressure. So the next is incidences. So sickle cell anemia is most common in people with African, Mediterranean, and Caribbean ancestors. So sickle cell anemia is most common in inherited blood disorders in the US. The 70 to 80,000 Americans have this disorder. So 1 in 500 African Americans and 1 in 1,000 Hispanic Americans will have this disorder. So the next is the ultimate cure, gene therapy. So first is correcting the defective gene and inserting it into the bone marrow. Second, turning off the defective gene and simultaneously reactivating another gene that turns on production of fetal hemoglobin. So, no real cure for sickle cell anemia at this time. So in the past 30 years, the life expectancy of people with sickle cell anemia has increased. Many patients with sickle cell anemia have lived into their mid-40s and beyond. So then the next is some genetic history. So the error in the hemoglobin gene results from a genetic mutation that occurred many thousands of years ago in people in parts of Africa, the Mediterranean basin, the Middle East, and India. Then, a deadly form of malaria was very common at the time. Malaria epidemics caused the death of many people. So, in areas where malaria was a problem, children who inherited one sickle hemoglobin gene and who therefore carried the sickle cell trait had a survival advantages. Then, unlike the children who had normal hemoglobin genes, they survived the malaria epidemics. They grew up, had their own children, and passed on the gene for sickle hemoglobin. That's